These are the notes for Algebra 2, Section 2.6, pages 113 to 117 in your textbook. They have to deal with scatterplots. A scatterplot is a graph of a set of discrete data points. I have an example here. You can see that our points are not lines. There are no lines in the data points. You can see when x is 1, y is 1. X is 2, y is 1, so on and so forth. And what we notice about it is that it's not in a straight line. It's bunched up. It's not exact. Now, there are some things that we need to know about scatterplots. For one, they tend to either move in a positive direction. That's the kind of graph I have here. This is moving in a positive direction. They can move in a negative direction or in no specific direction. So anytime we look at a scatterplot, we should be able to tell which of the three it is. If the y values move, tend to get bigger, if the y values get bigger as x increases, as we read from left to right, then that's a positive correlation. If the y values tend to get smaller as we move left to right, then that's a negative correlation. And if we have a bunch of points that don't seem to show a particular pattern, then that would be no correlation. We have an example. As you can see, my positive correlation, the points tend to go in a generally upwards direction as I read left to right. For negative, they tend to go in a downward direction as I read left to right. And I can see with no correlation, they're just kind of all over the place. There's not really a specific direction that they're going. Now, scatterplots have what's called a correlation coefficient. It's a number between -1 and 1, and it tells us how well the data points fit to a line. We started -1, and a correlation coefficient of -1 means that our points do fit pretty well to a line. They are very close to being in a straight line. But that straight line is negative. It's a negative slope. On the other end, we have a correlation coefficient of 1. Again, those points would be pretty close to a straight line. And if the line is moving upwards, that's with a positive slope, then r is 1. As we get towards the center, between -1 and 1, we would have 0. And if the correlation coefficient is 0, then the points don't really lie on a line. That would be one of those no correlation kind of situations. So what happens is, if we started at 0, as we move closer to 1, the points would be getting more and more like they were in a straight line. As they move closer to -1, more and more again, like they're in a straight line, but pointing downwards instead of upwards. Our graph here, we can see, looks not too far off from a straight line. It's a little bit, but it's not too far off. So this would have a correlation coefficient closer to +1 because the slope is positive. Here, I look at my values and I say, okay, if I wanted to figure out what the correlation coefficient is, I can see that these points tend to move generally downward, but they're not very close to the line. So I would not be able to say that the correlation coefficient here is -1, even though it's moving downward. In fact, I would say it's closer to -0.5, halfway between 0 and 1. So it's not very well formed. It's not very close to the line. But we can see that it's moving in a generally downward direction. In B here, we can't really see. There's not much of a direction that they're going in. So I would say that the correlation coefficient here would be 0. And our last one in this little bit, This is moving in a generally positive direction. And it looks to me like they're fitting to the line pretty well. So I would say that this correlation coefficient is closer to 1. Alright. The other thing that shows up when we talk about scatterplots are best fitting lines. Now, a line of best fit lies as close as it possibly can to all of the data points. So what we want to do whenever we're dealing with a line of best fit is plot the points. We want to estimate a line that just looks to us like it fits the data pretty well. And then we can use that line to make predictions. The line will give us an idea of where the point should be falling. So we have a situation here. We have the table that gives an average class score Y for each chapter test, X. So our X values are the test, right? The first test, second test, third test. So on the first test, the class average was 84. On the third test, the class average was 86. On the fifth test, the class average was 87, so on and so forth. The first thing we want to do is plot the point. Then we'll look at drawing a best fitting line and making a prediction. So after we took test 1, our average score was at 84, so I'm going to put a point at 184. The second test, the average score was 83. That's halfway between 82 and 84, so I'm going to put a point there. For chapter 3, our score was 86, so I'll put a point at 386. For 4, it was 88. For 5, it was 87, halfway between 86 and 87, or 86 and 88. And for number 6, it was 90, so it's 6 and 90. I've plotted my points. I can see that they tend to move in a generally upward direction. It's a positive correlation. And I want to draw a line that matches this data, because then I can use that line to make predictions. So there's not really any mystery here. I want to just estimate a line that looks like it fits the data pretty well. It looks like it's kind of in the middle of everything. Up here, you can see it would be way too high because most of my points are below the line. Same problem down here, most of my points are above the line. So I want to put a point right about, I'll say, here. That looks good to me. So I'm going to say that this is my best fitting line. Again, there wasn't any calculations involved. I just drew a line that looked like it fit well. Right? Now I can use the equation of this line to make predictions. To use the equation of the line, this is a line. I can find m and b and write the equation of the line in y equals mx plus b form. So that's what I'm going to do. B looks like is at about 82. So I'm going to say b is 82. And I'm looking for where it crosses. It doesn't seem to cross at a whole number here, but it does seem like it crosses at a whole number at 3 and 86. So I'm going to say that from 0.82 to 3.86, I can count out my slope. It moves up 2 and over 3. So with a rise of 2 and a run of 3 means it's a slope of 2/3. Using this information, I can say that the equation for my line is y equals 2/3 x plus 82. Now, I'm going to move my screen down a little bit. We can use this line, the equation of this line, to make predictions. Right? We can, for instance, it wants us to find what the score would probably be on the 9th test. That means that when x is 9, we want to know what the score will probably be. So we'll take x and we'll plug in 9. We have y equals 2/3 times 9 plus 82. To multiply 2/3 times 9, I multiply 2 times 9 and divide by 3. 2 times 9 is 18. 18 divided by 3 is 6. So I have 6 plus 82 gives me 88. So my prediction is that when the class takes their 9th test, the average score will be 88.